sheet the issue I was having.
Pardon?
I said on that was the economic sheet the issue I couldn't make sure.
Oh, do you walk in?
Yeah, so when I click on this section, it takes me to this. This is a different combination of like yeah, the problem. Oh, just when I go to this section, I can go to it is here, and I will do more place all those are options.
So if you haven't done it yet, please fill the sign up list. It is something that we will present in 8 days. On,
We don't know nothing about these topics. Is there any references for them, or
make a vote and then approach me if you need help. And during this weekend, I will share slides and recordings from previous years. So even if we do not cover something in the labs, you will see an example to inspire you.
whatever it is? No.
So the
Give me your credit.
to my understanding, this part was done last time, right? In red, and blue part is what we will be doing today. And then those things are kind of simple, natural, can be found online. Some of you already know it. I'm not going to cover it. And as time allows, next Wednesday, I will try to cover some of these things. And I hate symmetry, so if no one selects it, I do not mind. it's only for highly symmetric molecules that reproduce itself and after rotation, and it a little bit shortens the calculation time. But with modern compute power, it's not major enhancement. So if you are confident in your lucky star and skills, feel free to follow this menu and just process the data, the output files for a sequence of titanium dioxide oligomers that you did last time with Dr. Han and that you have submitted as a homework. I will slowly but surely do the things and give some instructions, but I do not consider me telling something bright, and you with your energy, curiosity, and young brains can complete everything quicker than I will explain. So when you do run Hartree-Fock calculation, you are getting, at least to our knowledge by today, we are getting two sorts of data: total energy, which must be as negative as possible for a stable molecule, and set of energies of molecular orbitals. And when you were parsing them out of the .log file, you notice that they have a label alpha and they have label OC, OCC, and VIRT, right? So it is like alpha, and then you have a list telling OC, and then set of numbers, and then VIRT, and then set of numbers. And for the homework, you were taking the last of the OC and the first of the virtue, right? And energy difference between these two numbers was coming into the gap.
Dr. Dimitri, can you please let us know again what are these two energies, occupy and virtue?
With greatest pleasure. It's one of my favorite subjects to talk. I will be very excited to discuss it, but again, for success of practical things, do not wait until I tell, go forward and do it. You may start following this prescription, and it is very easy. Yes? No, you can chop if you like, even if there are more than one choice. Just share your wishes. Letter to Santa Claus.
You should do two.
Remote host is on. Oh, this wait a little bit. Try to just board just
So this is the last point that we worked on, right? Yes. The N-core 4. Yep. Yeah. I think so. Is it right, Dr. Karim? This is the N-core 4 in the previous homework, this point that you mentioned here? N-core 3.
N equal with only one titanium. I'm starting with it. Right now, main thing is not scientific analysis of the data, but protocols, procedures, how we analyze the data.
So we should start with the smallest
yeah.
molecule.
Start with smallest just because it will be quicker. And
What is the start? The start is what here? This? Where is this? So we should find.
So one of the files that you have created last time was with Hartree-Fock data with 1 titanium. And when you scroll through this file, just want to be specific. I'm talking about this table for occupied and virtual, right? I'm not telling anything new. It is what you did last time, right? So when you are doing Aufbau principle, thank you so much. Everyone got some. No one selected the blue box, and it cannot be skipped. Make a second round. Everything should be covered. Otherwise, I will assign people myself.
No one covered the blue one?
Yeah. You want to do everything?
No.
It is too much. Chop it on several sections.
Wait, I'm sorry, I don't know. This one is, does it stop here or?
No one selected this JSON states. No one, someone needs to select this one.
No, it's not. It's a comment. I can sit down. So we should copy that for them?
No.
But that's what the problem is.
Yes, but it needs to be covered.
It's a comment.
You can think, and I can send emails, but.
I think I'll do that.
Okay, thank you.
Where is this?
So,
This shouldn't be enough for the
what are those numbers? Energies of what?
Homo and Lumo. Homo and Lumo.
Yes, HOMO and LUMO are only these two energies, but what are other energies?
The energies in different states.
I think it's the energy of, like the different energies at every.
Yes, at every level. And those levels, the term for them is molecular orbitals. So when you make multi-electron atom and you try to fill it with 1s, 1, 2s, 2, and so forth, you put more and more electrons. Here, the same thing, you put more and more electrons to the molecule. So you fill orbitals as they grow in energy. If you look, it starts with smaller number, and then it gets bigger, 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 and it increases, right? And this information about, like, we are looking only of energy of HOMO and energy of LUMO, but there are much more energies below and above, right? So those are electronic levels. Strictly speaking, the goal of this software and this method is to give the total energy of the system, but these auxiliary energies of molecular orbitals are critically helpful things that allow to analyze the properties of material. So you are computing the offset between energy offset between HOMO and LUMO, and it does determine several things: whether the material is dielectric, semiconductor, or metal.
So the summation of all these energies could be the total energy? Or?
So, summation only of the occupied, because if there is no there are electrons up and down here and there, right? If you add energies of all occupied electrons, approximately it will be total energy. There are some additional corrections because of electron-electron interaction. And if we promote one electron from here to there, it will be energy of excitation. If energy of excitation is close to 0, it is metal. If it is about like one couple of electron volts, it is semiconductor. If it is like 6, 10, it will be dielectric. Because there are no, in regular simple experiments, there is no power that will give 5 volts to, or it will be hard UV. So this band gap is an important observer that tells the conductivity, color, and also the energies of HOMO and LUMO. Some of you answered this Koopman theorem. They are energy of ionization and affinity, electron affinity, that are found in electrochemical experiments. So you are extremely powerful. With this data, you can just build any molecule you need. You compute this data and you can predict its properties. Only one person in the audience looks unhappy. It is Rebecca, who is exposed to a couple of cluster methods, which is more precise. And maybe you are aware of the shortcomings of these approximations.
No, I was just wondering, is like is it like HOMO and LUMO, is it like switched on the
Oh yes, thank you. Absolutely, yes. Now everyone happy. Good. Many thanks for the correction. So, in some, if you would have this amount of knowledge and practical skills and facilities by like 70s or up to mid 80s, you would be like on the top of the globe for doing computational research. Today there are a little bit more things. Now, what if you are not interested in simple molecules, but you want to do materials, like quantum dots, metals, interfaces, sensors? Typical objects in engineering do have like a lot of atoms, a lot of electrons. And it is talking about one individual orbital is not very efficient. Yes?
So by just looking at this table, how could I understand which one is HOMO and which one is LUMO?
Anyone wants to help to Faisal? You see, so you just go across this list. It starts from here, ends there, and you look the last one that has the label OCC. So this one will be HOMO, highest occupied. All that I have highlighted are occupied. Everything, when you continue here, starting from there, are unoccupied. Typically, if the system is healthy and reasonable, it is expected that all occupied should have negative value. Otherwise, it will be like explosive or a system that wants to repel electrons from it. A couple of unoccupied can be also negative energies. This system looks healthy. No, yes, please.
And by just looking at this table, can we decide that this is metal or
yes,
semi-metal?
absolutely, absolutely.
So how can we understand if this is metal or semi-metal?
Have you been here last Wednesday?
Yeah,
Did Dr. Hunt tell it?
I believe no.
Huh? I see diversity of answers. Some people show yes. So anyone wants to help to Faisal?
He said, but it was very vague. He mentioned maybe, but he said in vague way, Dr. Dimitri.
Okay.
He said this is the HOMO and LUMO. You have to subtract to find the band gap, and that represents what the metal is, like that.
Yeah. So you take this number, which is bigger, subtract this number, which is smaller, and for me personally, it is much more comfortable to convert it in electron volts. Maybe you like some other units, like wave numbers for spectroscopy or kilocalories. In electron volts, it's more typical for electronic structure and engineering of electric things. So you subtract these two numbers, multiply by 27 roughly, and then if it is more than 0.2 and less than 4, it is semiconductor. If it is close to 0, it is metal. If it is more than like 4, it will be dielectric. Okay? Good. So what to do if, you see, it is very, very small molecule. It is how many atoms? 9. 1 titanium, 4 oxygens, and 4 hydrogens. 9 atoms, and we already have like 50 orbitals. So if you take something reasonable, number of these levels will be so high that humans will get tired looking onto this table, right? It is objective. It is not because I am lazy to look on long tables. It is physically impossible. What if number of these orbitals will be 3,000? How can I navigate through it? And even if I can draw them in this way, it's not practical. There is a way to analyze and compare electronic structure of materials, and this set of energies is called electronic structure. So there is a way to analyze electronic structure of materials in much more human, in a way pleasant for humans. There is a way to summarize this set of numbers in something visual. And this something visual is called DOS, density of states. So first, I am going to, on this diagram, energy goes up, right? Now, I am going to redraw this figure, but energy will go from left to right. I'll put like somewhere is 0. Here is will be like minus 13 about plus 1, and here will be HOMO. Here will be HOMO minus 1. Here will be HOMO minus 2. Here will be LUMO, LUMO plus 1, LUMO plus 2. So I did nothing. I just rotated by 90 degrees. If the molecule becomes bigger, the offset of the gap, if I take the fragment of the same material of the larger size, like larger cluster of gold, or larger quantum dot of bigger diameter, or longer oligomer of titanium dioxide, the gap as a property of material is expected to be roughly the same, but density of states, how dense these sticks are to each other, will change drastically, to such extent that they will be not possible to discriminate by human eye. Question?
How to define the density of state?
Thank you. You are reading my mind and verbalizing my next sentence. So, how to define density of states? What if we assign a little profile, a little peak to each of the sticks, to each of the energies? So we assign one profile to HOMO, one to HOMO minus 1, one to LUMO. Okay? And then, so it will be so many functions, as many peaks. And then I add all these functions together. If I add them together, they will look like peak, 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 then nothing, then peak, 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 right? That's it.
So what is this new diagram?
Density of states. So this is
Level of energy.
DOS, and this is energy. So it represents the same information as set of these levels, but it summarizes it, like no matter whether you have 10 levels or 10,000 levels, it will be same style of image. If you want to compare a system with 10 atoms and 100 atoms, or the amount of these numbers will be drastically different, and it is very hard to compare. How can you do it? Present it PowerPoint with table that has 1,000 numbers, no one will listen to you. And if you do this, if you summarize these levels into this diagram, it is very easy to analyze. You just glance on it and see, oh, gap is open. It is a dielectric, right? You immediately analyze the property. Gap is more than 3 electron volts. It will be white powder, with guarantee. Typically, metals, if they reflect, they can be shiny. But if they're like tiny powder that doesn't reflect, it will be small gap, will be black. Gap bigger than 3 electron volts will be white or transparent, like a glass, dielectric. And if it is between 1.8 to 3, then it will be colorful matter. So the gap answers about the color and transparency of material. Gap describes the conductivity, so it's an important thing. Now, I believe everyone understood this ideal in a lay language. Now, how can we mathematically put it up? So I will do it twice. Once in a rigorous way and another in a practical way. So rigorously, so this will be E luma plus 1, E homo. So generally you have energy sub I, where I is number of orbital. But this function is continuous, right? So we need energy minus I. So if these two numbers are equal, then it will be 0. And then we put here delta. So delta is mathematical function which has value equals infinity when the argument is 0, and 0 if argument is non-zero, right? And then we add here summation over all orbitals, just all values of index I. And we call it DOS of energy, right? So here we go summation from all orbitals. This is a very simple thing, but it is a key feature of the rest of the course and of your projects. So Salim has volunteered to add this to orbitals, but I later may look and give this subject split on many people because everyone needs it. From now on, any homework will include calculations of those, and it's unavoidable part of the course. Now, did you ever seen function that is equal to infinity, or can you plot infinity on the computer screen? Right? Have you seen the function that is infinitely thin? Mathematically, yes, but it's not possible to draw, right? So there is an approximation. So delta function can be approximately I represented as e to the power I minus e minus ei square divided by sigma 1 square root 2 pi sigma. This is the function that Stephen may recognize. Well, any of us may recognize, but who is author of this function? Let's try once again. You can just give only the first letter of the name, of the family name. Rebecca, did you saw German banknotes before European Union? What was the port like in America? There are portraits of presidents. What were the portraits on Deutsche Mark? The name of the designer of this function on the 10 Deutsche Mark banknote. Yes. So it's Gaussian function. So delta function is approximately represented by a Gaussian function. And by setting up width parameter, so let me draw it. So Gaussian function has this shape, and the width parameter is here. But if we set up the width parameter smaller and smaller, then it will become narrower and higher, right? So if we practice the same equation, but replacing delta function with Gaussian, it will be very comfortable implementation of this idea, density of states. How to select the value of this parameter, of this width parameter? There is a really great hint from the Mother Nature. By now, we are not doing molecular dynamics. We are doing 0 Kelvin. We have nailed down all ions. But in a realistic situation, all ions are oscillating with thermal energy. And energies of all orbitals are slightly oscillating or fluctuating. And the energy of fluctuations, because of the thermal motion, is approximately equal to Boltzmann. Now we have Boltzmann times T. So we can approximately use width parameter equals to thermal quantum, which is like 0.25 electron volts. Huh? Room temperature. Well, maybe 27, but whatever. So, we do have 2 chapters to cover today. 1 chapter, implement this concept. It is already implemented. Run appropriate scripts to convert output from your log file into the image like this one. Okay? And now you have, please, everyone is encouraged to ask questions, but I think we got the basic idea, all of us. Now we need just to practically implement it. The homework will include to draw this image for all of the models that you did before. And as soon as you do it once, it will be a very quick procedure. It is not much. Second chapter that is we need to cover today is plot spatial distributions of molecular orbitals. This is my favorite subject because it's artistically appealing. So I may leave at least 20 minutes for the second chapter. If you live by this time, you'll just watch recordings. Okay. So let me distribute it. It has been sent by emails, but I would like to share it in printed form, just in case. Oh, yeah. Thank you. Oh, yeah.
I still have problem. I couldn't find this. These files are in your directory? No.
Oh, please do calculations in your directory.
So, but what is the first file? Gauss gap.
I will. If you understand what it is, please go forward and do.
But
If you need comments, just wait a little bit. I will cover everything.
Okay.
I just need a sip of a doping. So the email that I have sent includes this equation, and then there is a protocol. So this symbol, like caret, is not needed. I am going to my directory, and every of you is encouraged to go to your directory where you have completed the homework where you were doing the last lab, right? Previous lab. And if I'm lazy, I can just copy paste the stuff from here. So I'm going to the directory and looking that there is this file. Now I am so I'm running this script. So Perl is like an interpreter. It's not my job to explain what is Perl, but it is interpreter that takes as scripts for commands. The script that does the job is stored in on this server onto this path in binary. Then you put the empty space and give the name of the output file that came out of your Hartree-Fock calculation for your like smallest titanium dioxide model. So it should be something.log.
So, excuse me, what was the previous one? The PL?
Perl?
Is a file?
No, Perl it is a like language, computer language.
Oh,
We need to specify because how else the shell, how else the computer will know which interpreter to use. Like, in this line, we are going to speak Perl language. So then explicitly show the link to the script, and you do not need to type everything. You type sufficient number of symbols that it will be identical and click tab and it will continue the whole name. Then space, name of your output file, .log, and then space and 4 input parameters. So the meaning, there is a meaning for this input parameters. If you see this image for the density of states, any numerical line, any numerical figure is composed of points, right? Anything we show on screen is pixels. And we need to identify how many pixels will be used to represent this line. And number of pixels can be much bigger than number of orbitals. Like here we have about 50 orbitals, and I select to have 1,000 pixels. Okay? Huh?
Say it again.
1,000 pixels. 1,000 grid points.
Yeah.
And I'm giving just an example. When you will be practicing it yourself, you can change this number and see how results are.
The grid point is bigger than the pixel.
Number of grid points is natural to select number of grid points larger than number of orbitals. Like you have 50 orbitals and 1,000 pixels, or you can select like 2,000 pixels. There is no reason to select more than 2,000 because it is an amount of pixels on your screen. Next parameter is width. Is how broad this Gaussian is selected. Or maybe it is like square root of it, but it's related to width. Later on you can practice and try a little bigger and a little smaller number.
I think the generally there is 0.01.
Yes, 0.01. Yes, thank you. 0.01. Yes, and please note that there are spaces here and there and there. It's one space. It's just maybe not very much seen, but one needs to separate these entries by spaces. Then the number 3.
So 0.01 is the bandwidth, right?
Yes, it's a width of this individual peak. It is a width parameter that we enter into Gaussian profile.
Very good.
And then last two numbers, 5 and 5, I need to explain.
So it should be a bandwidth. You have a maximum.
Right, right.
range.
If we look on this list of orbitals, you see that it starts from minus 20 atomic units, which will be like minus 300 electron volts.
Okay.
Maybe you need it if you do X-ray detectors. But if I'm thinking about simple chemistry, catalysis on top of optical properties, I don't care what happens on minus 300 electron volts. And it will be a lot of garbage information that I do not need for my analysis. So I need to focus only on narrow window. So many electron volts down from HOMO, so many electron volts up to above the LUMO. And these two parameters specify like how start 5 electron volts before HOMO, finish 5 electron volts after the LUMO. And then after you type this command, hit enter. So if you do it, and then it writes some, it tells that it is processing, and upon completion of this command, there will be 4 new files.
What was LSL?
What?
What was the last comment that you used?
S-
LSL.
List?
And what about the dash LT? What does that mean?
Arrange. Long list arranged according to the time when it was created, and show on the head of the list. So please practice this command, and I just want to go around and make sure that you all did it successfully.
No, we don't. We have the gap just between the HOMO and LUMO. But for each of them, it's not the gap between them. Right. So each you mean each individual gap? What's the difference between them? It should be a step, I think. So we have 2 new point EOC.
I'm very
I'm slow as well.
This week.
I think it was misspelled instead of double was single. Sorry. No, it's always spelled. Make what we
I'm not doing it.
I give the templates.
Do you have anything else for it?
Just open for shoulder.
This is the my name. Yes, that will be the
There's no AI.
No, this is my name of the file. It's my file name. More. The name of the file. No, this is here. Yes, the file name here is A1 OPT. So A1 OPT does log, right? But when I open it, there is nothing. Moment.
Yes, how many
So
Yes.
there is here. Okay. But when I open it, there is nothing.
And you will look inside this file and see what
Where are we?
Again, is this the states?
Yeah, but I don't know why my file is empty. There is nothing to it. You wanna have a seat?
No, I'm fine.
It's,
Would you like to view the file?
no.
Doesn't matter. So,
I run this file, okay? The optimization of A1. A1 is the first file that I
for this job, it is better to do single point because it saves.
I utilize that geometry. It's difficult for this. But for geometry, it's for.
Wait, we do something, but I'm giving one that it will not. So.
A1. You wanna change the.
No?
You
No. copy by time. Okay?
Okay, thank you.
Seriously.
Thank you.
Also the X means the audio
And-
energy.
yes.
So for the difference, meaning that the Y also 2, the distance is different.
Yes, exactly. Yes,
Different.
yes, yes.
It depends on the orbital.
Yes.
Different shape.
Yes, yes. Whew. Very good. So some of you have already looked inside these files. If we look inside this eOC, you see it is just parsed out of the Gaussian output. If you do virg, it will be unoccupied orbitals, and if you look on if you look on the E underscore and then name of the output file, it will show the list of orbitals, which is a little bit more comfortable for analysis. So instead of writing them into row, it writes all orbitals in the column, and it is already converted into electron volts. So orbital 24 minus 13 or minus 49 in atomic units, and it does have 2 electrons. Orbital 25 unoccupied has 0 electrons, and it is minus 0.3 electron volts or minus 0.0 something in atomic units. Now, those were 3 files, and the 4th one is this DOS something. This has 1,000 lines that as humans we do not want to read. WC is not a bathroom, it's word count, and it tells 1,000 steps because we requested the 1,000 grid points. So the energies, first column is energies, last is energies shifted from Fermi, and those are small numbers that will come into here. If you like Microsoft Excel or Origin, you can take this file and draw it with your favorite program. I do not like Microsoft Excel. I am greedy to buy a license for Microsoft Origin, therefore I'm using the GNU-plot, which is 30 years old, obsolete software for drawing lines, but it is high quality for publications and it is free. So next, you already did scientific part. Now we do scientific communications, how to represent this file in a graphical form. So I'm going to copy the file that I have created into more generic name, dos.log. So I'm copying this file, cp dos blah blah blah, into dos.log.
To open in Gauss view?
No Gauss view. No Gauss view. Then next step is I'm going to type this command, GNU-plot underscore and then name of the script. And it will be immediately completed. If you are curious, it is a very short script that tells plot content of the file dos.log using column number 1 as x-axis and column number 2 as y-axis with lines, and to put the output into the file dos_go9.ps. So this plot command is the only important thing. The rest is just little formatting. So after this command is executed, Let me do it once again. GNU plot underscore bin GNU proc underscore DOS underscore Gauss. There should be one new file appeared in the directory. DOS underscore geo9.ps. Okay? So PS is obsolete 30 years old format for graphical files. Some of them, it's not standard today anymore, but there is a quick way to convert it into PDF that all of us accept and use. So the next thing is PS to PDF write, WR, DOS underscore GO9PS.
These are Linux commands that are.
Huh?
What?
It's standard commands in Linux. Just convert from PostScript to PDF, and if you log into different cluster, it will be there.
Okay.
It's not unique for this. And GNU plot is also standard. This little script is something I quickly typed, but the GNU plot is a standard software that is included in Linux distributions. So after completing this command, I am inspecting the directory once again and observing that there is one more file, dos underscore geo9.pdf. So after I observe that this file has been created, I want to pull this file into the local computer. So personally, I prefer typing a little secure copy SCP command, and this manual has it typed. But we can also do simple thing, and
It's black.
go into shared. CHEM676, and then I'm going to trying to find myself number 6. So there is the symbol of PDF. So I do want this file, and I will try to just drag and drop it to the desktop. Just take it and put it here. So if I do not want to do a SCP command, and then I open it. Yes, absolutely. And I will go around and make sure that everyone can do it. So this is what should be obtained. So those are very narrow Gaussians. If you choose width parameter a little bit bigger, it will be more pleasant. They will be a little thicker. But this one corresponds to HOMO. This one corresponds to LUMO. And you can visually see this is so much energy between HOMO and LUMO. This is definitely a dielectric that will appear either as transparent or white powder. So it will be not, you can see through. Okay? I'm going to make a circle and stop by each station and check that you are getting image images. not because I'm taking very quick, it's because I'm explaining something. I just hit enter. So we need to copy this stuff into G. That's it. Right? You can check it. That's it did create this. And if I'm curious, what is this script? I can just. It's quite simple. Much simpler than you think. And then we need to convert it from possible to ideas of PDS to. Make sure there was a PDF. Those are directives and files, and there will be one. Not the two directives, but a link. So let me suggest, since you all are very busy and time is limited, do not waste it only for learning. Contribute it as an effort towards homework. So as soon as you see the figure, copy paste it into Word or PowerPoint, right? By catching screen, making screen capture and pasting into PowerPoint. So that you do nothing for free, any document, any step that you do. Okay. Super. You have a bigger.
Less number of points.
Very good. So if you will do the same things for little bigger models of quantum dots, you can help Eric and your own research substantially, just to do experiment plus theory calculations right away.
Yes, and you were talking about like if we were having many different variables or many different, like even if it was one quantum dot, for example, there's a lot of atoms and so that means that if I have to plug this, how would that be?
Oh, it's same, absolutely the same protocol. You change nothing. As soon as you have a model of quantum dot, that the protocol of doing calculation and analyzing the data is absolutely the same. It will take more time for computer, but for you, no. You submit job and then you go. Super, excellent. Can you copy this file into like Word or PowerPoint? Yeah.
Sure.
Maybe screen capture.
Like after we created the PDF, does it like stay in that directory where we created it, or is it just?
Yes.
So you want it in a Word document?
Uh-huh. Yeah, good.
Okay.
And then you do it again and again for different models and it will be your hope.
Okay. So for the software that you use,
Uh-huh.
what's the name?
GNU-plot.
How do you spell that?
It's written here. It's the name of the software.
Okay.
So if you look for like Google GNU-plot, you will see it.
Okay.
And it is a standard part of Linux distribution. It's everything with the word GNU means free.
Okay. Nice. Thank you.
Yeah,
I have done this one as well.
Okay.
Yeah. So, but I am just a little bit.
you can redo it with a little different width parameter, and then it will look nicer.
Okay. So the thing is, why I cannot do it in Linux? It always says permission denied.
I understand, and I try to. So.
Yeah, I downloaded it.
Yes,
through the-
I understand, but you can
Okay.
underneath.
Yeah.
See,
Okay.
because on this local, this is not your personal computer, and they have protection. You can write only in your subdirectory.
Okay. 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 I do understand. Okay. Thank you.
I see you're progressing. You need to teach this course instead of me.
Why is this only showing like these three and not the like?
Did you optimize geometry?
Yes.
It happens.
Okay.
If one looks for density, like there are several degenerate orbitals of very similar energies, and actual states will add them all together.
Okay.
So molecular orbitals are helpful, but strictly speaking, they are not observables. They're just auxiliary quantities. So do not worry on general scientifically, and do not worry because our task today is not doing science right now, but just get the protocol.
Okay.
Okay.
Yeah, this is just a name, am I right?
Yes.
DOS. So can I choose different name?
Then, so this script, it will, if you look inside, it will intentionally search for the file with this name. Then you need to change the script.
This, yeah.
If you change name here,
DOS? Yeah.
yes, you need. You
Like
need
DOS 1, so I have to like DOS 1.
No. You need to copy the script into your directory, open, edit the script. It's much easier to use generic name here.
Okay,
There is-
that's why I was not finding the name, because for the different geometry I was putting a different name.
The best, I will probably address it to everyone right now. So a little comment to everyone. There is a homework that suggests that you will do the same density of states for all models that you computed by Hartree-Fock before, like set of oligomers. And there is a little ambiguity. Probably you were doing all calculations in one directory, and this protocol uses generic names. For each model, it tells rename it into a dos.log. So you can do it and immediately save image into like Word or PowerPoint and do not care. One thing. Another thing, if you really believe that you are doing great science and you may need this data again, which who knows, then create an individual directory for each model. Like create a not individual file but individual directory. Directory is titanium 1, directory titanium 2, directory titanium 3, and then you arrange things. And I will give the suggestion again and again when it will be time for new software, when it will be time for your projects. This practice and skill to open new directory for each calculation is very helpful. Even in this short, objectively it's short couple of months courses, there will be so many new models and calculations that if you do not design your own structure of subdirectories, it will be like not possible to find your files. So just it's a suggestion ahead of time, plan how you will name your directories. For homeworks, it's okay, it's easy. But when you start project, and by your natural curiosity, you will start creating more and more models and more calculations. And if you do not write like flowchart how I name my directories, you'll be dead in the sense of a project.
This is the command for the...
Nasrullah knows what it is. Talk to him. He will give you a very good suggestion. I will put you on the recording because maybe you say something.
Okay. So I have to copy this thing. So this is the secure copy from this.
Okay. So let's.
I have to just understand what is the meaning, what is the target file, and what is the destination.
Okay. So in order to do that, so this is your first terminal. You need to open a new terminal here.
Okay.
And in the new terminal, you need to go to your local computer.
I forget.
Okay. So this is my local computer. Drives, C drives, users, and then in the user you also have a profile in your name, and then go to desktop and then type this. So SCP, this is the remote terminal.
This
is the local terminal.
Local terminal.
And this is the remote terminal. So we need to copy file from the remote terminal to this local C drive desktop. Okay. So first SCP, then what is the remote terminal? This is the remote terminal. And what is the folder address? The folder address is type pwd, you can find here, home, credential, this. So this is the remote terminal address, and this is the folder address of the folder. And this is dot. If you put dot, that means those files will be copied in this local.
Dot?
This is for another thing, this is for a new file, but if you type just those, it will be downloaded in your.
Okay.
That is one way, or
I can copy from the
yeah,
Thank you.
So this is yours.
If you're done talking, can you please bring the microphone so we can say something?
It will be later. It's kind of helpful for us.
Yeah, thank you.
Actually, I forgot. Yeah.
LAB6. See, now the homo is different number, 38 instead of 24.
Yes.
Okay. have this one. Okay. Copy this one into those little. Okay, and now we are doing what? Pin. Okay. I need to make a little advertisement. So we need to practice to respect to each other as researchers and understand that if you use the shared directory, you can damage files that others are using. I'm not accusing anyone. I'm just suggesting good practice. So there is a file that you use, this little script, right? And we all have privileges to make like VI, go there and change stuff here. But if I use it here, if I change the name of DOS then it will stop working for the rest of the class. So if I really want to change the script, I need to rename it, and better I just copy it, cp script, into my local directory. And now when it is in my local directory, I can modify it and call it, let's say, DOS2. And then if I DOS.log into DOS2.log, and now I do GNU plot Now it creates this different file. But if you want to practice a little bit of programming, it's very encouraged, but try to do it in your local subdirectory rather than in the binary which is accessed by the whole class. Make sense? So there is nothing wrong with it, but just think of our arrangement.
So nobody get hurt.
Exactly. I know that if someone did in the class did unpleasant thing for you, you can go into directory and delete everything. Do not do it, please. Yes? Everything is fine on your side?
Yeah.
Okay.
The copy comment, we both get the same error, no such file of directory. So we have this file here, okay? DOS the value 0.01.
Okay, let me grab a chair and that's okay.
So I delete all the files and start again.
A2 means
There is the second instruction.
is it what you want?
Yeah. So what was the problem?
I don't know.
Doesn't like me.
Look. 0.01 and 0.01.
Oh, it cannot.
Oh no, it's very unforgiving. It's like a silly robot. It will pretend that it doesn't understand you. You need to be literal.
Okay, so.
And the way is you just start typing as much as you can remember, then tab, and it will continue.
I thought I did that, but okay.
Okay?
Okay. You did the same?
Yes,
mistake?
could you do the next step? I'm necessary in next step.
Having the history.
Yeah, glue. That's right.
So, new file.
What is the meaning of head here?
Just like
So this sort with the time, right?
yeah, and I do not want to see if I do not do head, it will be longer list, and I want to see only the top of the list. Head, like only 2 files or 1 file. So many files.
Yeah.
So now
So you already
yes,
generated this
now
format?
I converted PS to PDF, right? DOS. Checking once again. It's PDF file. Okay, and you were, and now you can. No, not this one. So, if you want to copy it by command line, ask Nasrullah, and I'll show this shortcut. And when it will be time to do projects, if you have so shared. Shared. So here I'm doing PWD. Shared, and then go over.
So 3 years back, we can find the.
And then okay.
Yeah, makes sense.
So if there is an opportunity to come with your personal laptop, it is not necessary.
Unfortunately, yeah, we prefer, but we have Mac and mobile.
With Mac is better. With Mac you do not need mobile external.
So
Mac has a generic X connection.
we can use terminal.
Yes, exactly. So right now it doesn't matter, but as closer we approach the projects,
for the next.
so that you can save intermediate data, and it will be you create your personal environment. You do not download things every day.
Sure.
When I enter this command, there are issues here.
Thank you, Zaki.
Oh, my pleasure.
Just work with Dr. Killingham. I'm sure there is a trick.
But there was a warning.
No, I don't see the warning.
What?
It is the stuff that I was telling. So I do not know who, but one of our colleagues in the classroom started playing programmer and was modifying the script.
Okay. Not me.
Now you can type everything you want, and if you want to now you can.
So is it more or less clear for everyone about this density of states? So it will be homework for next Tuesday to make this density of states images for a range of these oligomers, and if possible to your silicon plus benzene ring adsorbate, which we were drawing at like lab number 2. So one can also do Harvey-Fock and see consequences on the density of states. So there is about half an hour remaining, and I'm going to switch the gears and show much easier and much more pleasant part of molecular orbitals. So even if you do not care about science, it appears to visual and artistic feelings of humans, because sometimes these orbitals look like flowers and look just generally look good. So suppose that I am in the directory where I have completed Gaussian Hartree-Fock calculation. Now I need to have the file CHK. So Rebecca was presenting on this subject and telling it is like when you are playing computer game where your opponents can like kill you, you can save yourself before and then restart. So check file is this meaning. In addition, it never try. I'm serious. I'm going to tell something that you shouldn't do. So never try to do the command more space file.chk. It will be unreadable. It will be like for humans. It will be like random collection of like points, exclamation signs, numbers, because it is a binary file, and it may corrupt your terminal session. So later on you will type one key and it will show another symbol. It's not for humans. But CHK file includes information on molecular orbitals. When we are considering materials in class, we are considering the Fock equation, one electron Schrödinger equation for orbitals, which are written like. Do you give me permission to erase the stuff? Okay. Everything here is correct. I just need more space. So basically, f phi I of r equals E sub I phi I of r. And in the class we consider what this Fock operator is. But in fact, Hartree-Fock protocol solves this Fock equation and generates energies of molecular orbital, which we have analyzed with the density of state, right? And in addition, it finds this phi of r, which are three-dimensional shapes. You have already seen atomic orbitals, right? Which look like S, P, D, look great. Molecular orbitals, they also are three-dimensional figures. They are distributions in space. And those space distribution are saved in the .chk file. They are automatically computed. But we need a little skill, a little special protocol to extract them from there. And if you see this printout, you can observe that there's a couple of lines and then just click in the Gauss view. So before you start this procedure, let me show it here. Yes, it will be here. One needs to decide which orbital you want to plot. You have seen that in the list of orbitals, even for small objects, there are so many of those. And they are labeled by numbers. So generally it makes sense, it is mostly scientifically important to plot HOMO and LUMO orbitals. And you know, we already found that for this smallest titanium hydroxide, HOMO is number 24, LUMO is number 25. So probably I will need orbital for I equals 24 and I equal 25. This is important information just to plan ahead. Now, in order to convert .chk file into something readable, one needs to do this two commands. Convert it into more readable format, in some sense unzip, but still do not look into, just type form check, space, and then your Gaussian output .chk, and then you'll see that there will be formatted chk file. And after you do it, there is a specific command line tool
that converts encoded data about molecular orbitals into three-dimensional patterns. Phi sub I of R equals summation of all ions, summation of all principal magnetic orbital quantum numbers, and then there is an expansion coefficient for orbital number I, ion number I capital, and then this N, M, L, M times chi of R minus R capital sub I N, L, M. Do not focus too much on this equation. We will cover it either probably tomorrow in class. It's a little heads up, and it is not in this protocol. But I'm just giving general idea what these commands are doing. So in the FCHK file, orbitals are written as a set of coefficients, discrete coefficients, in front of atomic orbitals. This is very good way to store information. But number of quantum numbers, number of ions, number of molecular orbitals is quite high, and for humans, numbers are not good. Just by our nature, we perceive visual information much better. And these three-dimensional atomic orbitals, I can put AO, through these linear transformations are converted into three-dimensional molecular orbitals. And these molecular orbitals as three-dimensional maps is something that we can analyze and make scientific conclusions. So this procedure of converting set of coefficients times atomic orbitals into molecular orbitals is implemented in this command, CHEM676 space O, which stands for orbital space, MO for molecular orbital equals 24, because I want orbital number 24, which will be HOMO for this small model space, name of the file .fchk space, and then this one is just name of the file three-dimensional space map for this molecular orbital 24.cube. This is my choice, how I want to name this file. But you can type it, my most beautiful file for the HOMO. Nothing will get wrong. So I'm going to type these two commands and observe that it should generate this file. I'll do it, make a circle, and then we'll go to Gauss view.
It should be .cube.
.cube. Again, it will help Gauss view to recognize this file. But if you call it different way, it will not change the content.
So you should do it for all, for a structure, or
for today, right now, in class, we'll do it for 1 or 2 orbitals for the practice, to check that everyone can do it. For the homework, you do 2 orbitals for each structure, HOMO and LUMO. And you will need to find what is the number of HOMO and what is the number of LUMO. For each structure, it will be different number.
oh yeah, the number of the
I apologize for a little of extra work, but later on it will pay off. You'll feel much better in the rest of the course with this exercise. Okay, so I'm typing form check, and any computer system that has Gaussian installed automatically has this form check and CHEM676. It is a like natural part of Gaussian. Form check titanium 04 H4 CHK.
That was the final step?
Huh? No. Two steps in command line and then a couple of clicks in MATLAB. So after this command, I'm doing ls minus LT.
No, I mean after plotting this because I already finished the plotting of the.
Oh, then you feel free to depart or invest time into homework.
So today we don't need to send you anything?
No, homework is due on Tuesday.
So the do of homework was yesterday actually.
Huh?
The do of that you typed was for yesterday.
Actually, there's a mistake.
I am a champion of mistakes. And thank you much for correcting.
It's okay.
It will be next Tuesday.
Next Tuesday, yes. So that you can invest, you can spend time to do it on weekend. Otherwise, I know that you are busy and you have 1,000 other assignments and research and teaching and other courses.
We'll have fun in weekend.
Exactly. So if I'm looking, I see that there appears file form check. And after this form check, I'm typing cube gen space O space MO equals 24 space titanium blah 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 FCHK, and then type the name of the file, like I can call it mo24.cube. Why this command takes a little longer? Because it splits space. While it is called cube, it creates imaginary, like virtual cube around the molecule, chops it on about 100 points, grid points in each dimension. So 100 by 100 by 100 will be about 1,000,000, right? And this, and for each point, it will write the value of wave function. So since it is so easy, I can do also for the Luma. So I put MO25. Oh, there will be two things.
What you say in the same point? Same
No,
point?
I see. I request different.
But they generate names?
No, I use different. And now I want to launch Gauss View. And in Gauss View, I can open. So right now, I do not see these files because it uses a specific extension. But if I check for this cube, it will show these two things. So I select MO24 cube, open, and it shows nothing. It shows the molecule itself. But it is not the whole story. One needs to go to results, surfaces, select surfaces available, and click here, new surface. And then it appears this way. So
what does that mean, the changing of the volume when you go far from the nucleus?
Oh, thank you. Thank you so much for asking. It's again my other favorite subject. So I'm going to draw something here. Will you see it? So suppose that I'm analyzing one-dimensional functions. I'm just tell something about one dimension and then go to three-dimensional. So suppose that I have one-dimensional function which may look like up and down. Suppose that I am a zero-dimensional creature that cannot see these things. I'm just coming from here, like stickman, and I can watch only here. So I can only see one point. Then I can assess only how high it is, right? So I put the line that will show how high this function is at certain point. So I'm reducing the one-dimensional function into like zero-dimensional, into one number. Just remember it for a second. Now, what if I have a two-dimensional functions like x and y, and the function looks like a series of humps. And suppose I do not have ways for do three-dimensional plots. I can set up the ISO value like m prime and look for contours where this function has this specific value. Then instead of these two humps, there will be just two circles showing lines where this two-dimensional function has certain value. Good? Now I'm going to do the same thing for three-dimensional objects. I have a like heat map of the density for this function, but I cannot look inside. If I see like a balloon, I do not see the gas inside, right? So in three-dimensional object, I select those two-dimensional shapes that enclose, that goes along surfaces where the value of the function takes specific ISO value. Make sense? So instead of maps, it shows only like balloons, only surfaces. Surfaces, right. Therefore, this orbital, we all call like here are molecular orbitals, but more correctly is to say those are isosurfaces of molecular orbitals. And the stuff that we are selecting here, ISO value, is this number. So if I take this number bigger, then balloons will become smaller, right? So if I took bigger value, it will enclose only smaller area, right? If I select the smaller value, right surface, it will take the bigger volume, right? But it is only a way to represent this molecular orbitals. What else can we learn from this object? So in the center is titanium, here are the oxygens, here are the hydrogens. On which atoms we see this non-zero density, on which atoms these molecular orbitals are localized? Yes. So the occupied orbitals that are localized on oxygen are occupied, because oxygen is oxidizing agent and it pulls electrons to itself. You see? Oxygen is oxidizer, right? Oxidizing means pulling electrons. It's like, yes, taking electrons. So electron orbitals are in most cases they are occupied because they pull electrons from other atoms. They stolen electron from titanium, they stolen electron from hydrogen, so aggressive. Now, what if I open orbital number 25? I'm doing the same thing. Surfaces, contours, maybe 4 is a good number. Surface action, new surface. So this is the LUMO orbital, highest unoccupied. Where is it localized primarily? Huh? Titanium. What is the shape of this molecular orbital? No, it looks like a donut with two things.
dz squared?
Yes, dz squared. If you look on the previous one, it was 4 pi orbitals on the oxygen. The empty orbital, unoccupied, is on the titanium. which immediately gives some insight into chemistry. So by forming this compound, an electron from d orbital of titanium is withdrawn to the p orbital of oxygen, right? So titanium in this compound is 4+, so 4 electrons are taken from titanium, and oxygen.
Higher orbital to lower orbital. From higher energy band to lower.
These orbitals, energies of these orbitals are result of formation of chemical bond. If you take the atoms and put them far away from each other, shapes of orbitals and the pattern of occupation will change. Please try to repeat it. I will make a circle and make sure that everyone can do it, and I want to do at least one more orbital because it will be very pleasant and interesting to my understanding. If I do one more unoccupied orbitals. If you, yes, if you need to, it's fine.
So thank you for your appreciation.
Oh, my pleasure. So I did create the molecular orbital 26, which will be LUMO +1. And look at that. Let me hide it and do it maybe. So where the majority of electron density is now? It's again on titanium. So it's orbital 26 +1. And instead of this donut with tails, it looks like flower with 4 petals. So it's another orbital of d symmetry. So atomic d orbitals on titanium contribute at most 2 unoccupied orbitals of titanium. There is a little admixture from oxygen, but they are in a smaller proportion. And it is literally what is shown here. So we have atomic orbitals from different atoms, different quantum numbers, and they are entering into molecular orbital with different proportionality coefficients. Okay? So I'm going to circle around and make sure that you can fabricate these images. Yes?
So you're going to discuss about those things tomorrow?
I will try my best, but not at the level of practical things, only theory behind it.
Yes, I didn't catch how this orbital are occupied or unoccupied.
Okay, I'll try. I'll try my best. Let me bring the microphone in case we discuss something useful.
I just got excited. It's just like started this, and I keep running into this error, and I'm not sure exactly what to do because I have a file.
It is 0. See, number 0 means it is empty.
This the UF. Oh, okay.
Let me do it once again.
Go ahead.
The name of the file should be the one that you assigned. So you do have this hard fork, CHK, and it is not empty. Now I literally copy what you have, your file name.
That didn't, yeah, I kept getting that error. No, so that was
Okay, well, let's just copy a similar file from my directory for your practice.
Okay, I have to go. I just need to make sure that I will
But it will be like 30 seconds if you.
Okay.
So. check.
Oh. Well, I guess I was something wrong.
And then now just do this.
Do you think my file is corrupted?
I don't know, but you can read.
I'll read it.
Hardy Fog is very quick calculation. You can try
Yeah.
to read. Orbital.
Looks good. All right, thank you.
And then you should be able to open it in Gaussian. All good?
Yeah.
Okay.
So could you please just show, these are showing the orbitals of regarding this, like we can see that around the oxygen atoms we can see those.
Yeah. But you selected 15, which is too small. For this dimer, it should be like 39. You need to find where is the HOMO transfers to LUMO.
So we need to first look at that dos.log file.
Yes.
Okay, and then we.
Yes.
Okay. Okay.
You're writing
Okay.
scripts.
Yeah, it was easier.
Okay. All good?
I want to say, I'm watching this picture because I changed my orbital.
But you can a little announcement. As you generate orbitals, since it is towards your homework, please try to make screen capture and put them into your PowerPoint or Word and label them appropriately, so that you do not work for free. Everything is contributing to your reports. So you can hide it. Or
Remove side. Just remove the bottom one.
So larger value of ISO value, larger ISO value, more compact pictures.
More complicated. This belongs to only
Oxygen.
oxygen.
Yes.
But when I am giving it a smaller value, then it's covering the whole molecule.
Yes, it is. If you got this description. So, if you have two-dimensional structure, depending on the choice of ISO value, we will convert it into circles of different radius. Larger ISO value, more compact circles. Smaller ISO value, it will be more distributed circle. Okay, so it's like inverse relation.
So it doesn't show the energy value larger than MO.
It's not energy, it's ISO value. ISO value, it's the same orbital, but it different ways to represent it. And some of you may feel a little embarrassed if you take very small ISO value, it will cover the whole space. You see here, if the ISO value is selected at very small value, that it will cover everything, right?
Or if you choose a very large value.
If you choose very large value, then it will be localized very close to ions, or sometimes not visible. So it is normal. There is no science behind it. It's only your way to represent it in a more optimal way. And if you see that it is composed of more than one atomic orbitals, so it is simultaneously on several oxygens or simultaneously on titanium and oxygen, it is because atomic orbitals are combined in a summation all together. So it is normal. It is what is coming out from these calculations. Okay. I was good on your side?
Yeah. Yes.
You were able to plot it, right? You did plot them?
I'm having some problems.
Okay. And if you need to leave, please do. There will be no more new information today. We're done. So the file is 0, so it will not work. I don't know why, but let's try. Dot CHEM676. So right now I don't know what happened, but if it shows wrong, I may need to redo the particle calculation. Typically, if you do not do optimization, if you do just single point energy, it should converge and give healthy file. So let me just for illustration copy. Here.
I was going to say, if I have time for the rest of this week, I'll turn this in, but I'm really busy.
I understand. I understand. This is like critical, important, but you may have better priorities if you're busy with other things. You may just come up with to practice it later. But put it into your schedule because it's like a critical step for assessing the rest of the course. It gives some concepts, and you already got them, but practicing a little bit. June, at least no errors. And open it in Gauss view and check if you get these images. Yeah, I understand. It's just I don't know if this class will be offered next year. When you eventually will be a student, and if you want to make it part of your research, you're investing in the future. Sometimes next, right now time is up. I was in the conference and there was a very interesting presentation similar to what you did in the class for NMR calculations. And I'll maybe bring this more information about it, and it may serve as an idea for your project if you decide to do that. More questions? No. Okay, then I'll complete and stop. But please copy paste images into PowerPoint.